Alright, hello Trig. So, today we're looking at the product rule. And if you're looking at the section in the book and going, it's the product rule and the quotient rule, Miss P, yeah, we're going to split that up into two, not because either of them is particularly bad, but because the quotient rule gets kind of long and kind of messy. So we're going to hit the product rule first on its own, and then we'll deal with the quotient rule. Okay, so that'll be the next video. So, the product rule. Remember when we said that if we were adding or subtracting derivatives, we would just take the individual derivatives and end up adding and subtracting them, and we're good. Well, that doesn't work with multiplication. So the thing you're probably going to want to jot down is this. So if we want the derivative of two things that we're multiplying, we're taking the derivative of the first one times the second one without taking the derivative of that, plus the first thing times the derivative of the second thing. And for now, just trust me, this works. If you want to see a whole run through of how you get this from the general derivative thing, feel free to check out page 154 in your book, but I figured you'd probably just flip through that section of the video anyway if I put that on the video. So it's there in your book if you want it. I'm guessing you're probably good with just taking my word that this works. Okay, so I'm going to assume you've jotted that down by now. So, what we're going to do with that is we're going to take it. And we're going to take the derivative of the first thing. So, and this is just power rules, so that 2 is going to hop out here. So we got a 2x there. Plus the derivative of 3x is just 3. Because that's a 1. 1 times 3 is 3. That gets knocked down to a 0 power, but anything with 0 power is just 1 anyway, and that 2 is gone. Times the second thing without taking the derivative of it. Plus the first thing without taking the derivative of that. Times the derivative of the second thing, so that 3 is going to hop out here. So I got a 3x that gets bumped down 1 power squared, minus 2 times 5 is 10. That gets bumped down 1 power. That's an x. And there we go. And there's our derivative. And honestly, you could FOIL that out, but if you were going to do that, it would probably be easier to do that at the start rather than doing it here. So it'd probably be easier to FOIL this than FOIL all of this. And I'm pretty sure the book didn't bother FOILing that out, so feel free to just leave that. And there we go. Alright, so in not terribly bad, just kind of long, the quotient rule's a little bit worse. Okay, let's try one more of those. Stick. Nope, not gonna stick. Okay. Alright, so same sort of thing. Couple things I'm going to rewrite first, though. So remember, square roots are really just x to the 1/2 power. 5 over x is really just 5 times x to the negative first, so I'm just going to rewrite those like that first. If you can do that in your head without rewriting the whole thing, and that's perfectly fine. So just remember, if we have a square root, that's a 1/2 power, cube root is a 1/3 power, and so on. If you have an x on the bottom, that's really a negative exponent. Okay, now we're doing the same thing we were just doing. So we're taking the derivative of this one, so that 1/2 is hopping out here. X, and 1/2 minus 1 is going to give you a negative 1/2 there. Plus 2 hops out here, times 3 gives you 6. X, technically to the first, if you want to throw a first down there, that's fine. If not, that's also fine. Not picky about that. 5x to the negative first minus 7x to the fifth. So we got the derivative of this times this without the derivative, plus this without the derivative. And I don't care if you call that a square root of x or an x to the 1/2. Just like I don't care if you call that an x to the 1 or negative first or a 5 over x. Either one. Plus a 3x squared. I shouldn't write while I'm saying something different. Times the derivative of this. So that negative 1's hopping out here. Negative 5. X to the negative 1 minus another 1 gives you negative 2. 5 is going to hop out here. 7 times 5 is 35. X to the 5 minus 1 gives you 4. So derivative of this, derivative of that, these two are the ones without the derivatives. And again, feel free to just leave that. If you were going to FOIL it, it'd be much easier to FOIL it back here, so just leave it. Okay, now, the other thing we're doing with this is if you looked at the book and you saw something that says find the equation of the line tangent to that at such and such a point, and that's why you came back to the video, that's nice. So let's say we've got this same equation here, and we want to find the line tangent to f of x at x equals 0. Two things you're going to want there. The first thing you're going to want is you're going to want the point at x equals 0. So we're going to go back to our original equation, which was our square root of x plus 3x squared times 5 over x minus 7x to the 5th. I should have picked a point that's not 0. We're going to pick a point that's not 0 because that would give us an undefined. So we're just going to hastily change that to a 1. Okay, that's better. It just took come out nice. In fact, it should come out nicer because now we'll actually have an answer. Okay, so I'm pretty sure the one in the book is 0, but that should be one that you don't have to do that for. Okay. So let's say I want a tangent line at x equals 1, so we're going to want our point at 1, so we're just going to plug in 1. So yeah, square root of 1 is 1, 1 squared is 1, 3 times 1 is 3, 5 over 1 is 5, 1 is nice, 1 to the 5th is 1, 1 plus 3 is 4, 5 minus 7 is negative 2, which gives you negative 8. Okay, so we've got a point at 1, negative 8, and then the reason we need the derivative for that, which conveniently we just found, is remember the derivative is really just our slope. So this is our slope of that original function, but everywhere. So now if we want that slope at 1, we're just going to plug in 1. Conveniently, 1 to the negative 1/2 is also 1. Times 1/2 is 1/2. 6 times 1 is 6. 1 to the negative first is also 1. 1 times 5 is 5. Minus 7 times 1 is still 7. Alright, and then plus, I'm just going to hop this up here. 1 to the 1/2 power is 1. 1 squared is 1. Times 3 is 3. Negative 5 times 1. 1 to the negative 2 is still 1. Negative 5. And then minus 1 to the 4th is 1. 35. Okay, so now we're just number crunching. 1/2 plus 6 is 6.5. 5 minus 7 is negative 2. Plus 1 plus 3 is 4. Negative 5 minus 35 is negative 40. And 6.5 times negative 2 is negative 13. Plus 4 times negative 40 is negative 160. Is a negative 173. So that's our slope. So now we just want a line with a slope of negative 173. So our slope is negative 173, a very, very steep line there, through a 1, negative 8. So now we're just taking that and we're plugging that into point slope form. So y equals m, x minus 1, either plus that negative 8 or just minus 8. And feel free to not distribute that. Point slope form is just fine. Alright, so there's our line tangent to that function at this point. Yay. Alright, and that is pretty much that for the product rule. Again, split this up because quotient rule's a bit messier. Yeah, product rule's not that bad. So go ahead and check out the numbers in the description below, and I'll see you in the next video.